Assalamu alaikum. How are you, my friends? This is experiment number 1 for instrumentation and measurement number 1 course. The experiment, or the first experiment for this course now, is the pressure gauge. How it's work, and how can we read it, and how can we check its accuracy. So our experiment here, what's the working process principles, and how can we read this pressure gauge and how can we check it. The main contents of this video will be three things: the idea of this experiment, the construction and the working principle of Bourdon tube pressure gauge, and the method of reading the pressure gauge. Then after this video, the student must know how can they start or how can they run their lab during the lab time. Now let's start for the first one, the idea of this experiment.
We'll talk here about pressure gauge. What is the pressure gauge? A pressure gauge is a device that gives you a reading for a pressure readings. It contains of the glass for side view and is covered by metallic cover around it, and there is scales inside this glass with the needles that indicate the values of pressure coming through the input inlet of this pressure, and this scale will give you the how much pressure is available. We have here readings for units, pressure units: kilogram per centimeter square, inch, mercury column, PSI. So we have here three. Now I want to read in this lab, ya shabab, you are requested to read the span, range and resolution, and to calculate the accuracy and also the average accuracy for this one. Okay, to run this one, just put it here and look at it. This one you call it the gauge for the measurements. Okay, we need a source, which is the true value source. Where is this true value source? It is here. This one is the true value source for our measurements. And also in next experiment, inshallah, experiment number 2 or 3, we'll utilize this electronic source. This electronics source, ABMX, we call it ABMX. But this one in the experiment, in the next experiment, inshallah, experiment number 2 or 3. But now in the first experiment, we'll utilize the manual source. So this is the true value. This is the true value, the measured value. It requested from you, shabab, to run this experiment in order to measure the true value with the measured value, to compare the true value with the measured value. Fill in the tables, calculate the required equations, and describe the results.
How pressure gauges works. So guys, this is a pressure gauge which is simply Bourdon tube type pressure gauge made from Vika. So guys, this is a Bourdon tube pressure gauge, which is nothing but the mechanical pressure gauge. So pressure gauge is an instrument which measures pressure by the means of mechanical movements, and the mechanical movements gets converted into the rotary motion of the pointer. So guys, this is the animation, typical animation of a particular Bourdon tube type pressure gauge. The media enters from the socket P, goes into the BT, that is Bourdon tube. The media can be pressurized air, water, or it can be anything else. The pressurized media enters in the BT and tends to expand the BT So the end of the BT is connected to the sector mechanism, or we can call it as the mechanical moment, by the means of this particular link, so that the mechanical moment of BT converted into the rotary motion of the pinion. So due to that rotary motion and due to that rotation, the pointer rotates and we get the reading on a scale. So guys, let us discuss the part of the pressure gauges and the specification. So guys, this is the black colored, which is known as the casing, and we can call it as a housing of a particular pressure gauge. We have got this is square socket having the threaded process connection at the bottom, which is a socket, or we can call it as a shank. So guys, this is the C-shaped Bourdon tube. Normally we can call it as BT, which is typically welded to this socket. That is, the welding has to be carried out. That is the welding of the BT and socket. We have got this particular assembly of movement. That is the, we can call it as a sector mechanism as well. Then upon that moment the dial is getting fixed. This is the white colored dial having the letterings on it by the means of this dial screws. Okay, and upon that dial our pointer get fixed particularly. So this is the initial assembly, and for the safety point of view, the safety of all of the dial and the pointer, we have this toughened glass in the last. So guys, in the terms of the material, the casing is made up of SS304 or SS316, whereas the Bourdon tube, that is SS316 or brass, can be used. In case of socket, that might be SS304 or SS316. In the case of movement, that is SS304 or brass only. So brass is cheaper than SS304. The overall the cost of the gauge gets reduced. For dial, we can use this black aluminum with white background and red lead.
This is quite an inexpensive gauge. Some of the better ones are going to be sealed, maybe even stainless steel, and filled with glycerin to lubricate and to keep the needle from vibrating. But I simply took off the front ring, which was pressed on along with the lens. And on the back were 2 screws, which I've taken out. Just a protective cover is all that is. And the entire mechanism here is brass, with the exception of the copper tube here, which is we call the Bourdon tube. And on the front, of course, there's a needle, and it's been calibrated with a little, and it has a little stop peg there, and the face. And this gauge goes from 0 to 100 psi, pounds per square inch, and you can tell this is kind of an old one, because the newer ones are also going to tell the pressure in metric, which is kilopascals. The Bourdon tube is nothing more than a piece of copper tubing that has been flattened and then bent into a circular formation here, and it's soldered to the brass, the square brass part right here, just soldered, and then it's also soldered on the other end so that it is leak proof, in other words, airtight. Now when the pressure comes on, the Bourdon tube attempts to straighten out. Now it's not going to go all the way, it's only going to flex a little bit. Now watch the needle as I turn the air pressure on and then again off. We're at 90. Now watch the Bourdon tube as I turn the pressure on and off. On, see it, try to straighten up, off, and it relaxes. Pressure's on, pressure's off. From this view you can see this small link here is fastened onto the end of the Bourdon tube, permanently fastened, and then there's a pin here, and then this link here links it all to the movement. So watch now again as I pressurize it again, and you can see what the linkage is doing. Here comes the pressure. So that motion is transmitted through the linkages and into the quadrant and into the pinion, which in turn moves the needle. And I'll show you another view of that. Never before seen on YouTube. Now I'm straightening up the Bourdon tube with my fingers, bringing it clear up to 100. And by the way, it takes considerable pressure to do that. But there's a movement in here. I don't know if it's going to show up or not, and it won't do any good to take the face off. I was going to take the face off. But down here on the shaft that goes to the needle, there is a tiny gear that we call a pinion. Also, there's a little spring right here too, a hairspring. And this is the quadrant here. That's another gear that engages with that little pinion. And as this attempts to straighten out, you can see there's a linkage here that goes to the quadrant, which in turn is spinning the needle, turning the shaft. It's a complete brass movement, made in USA, by the way. It must be pretty old. Now we've got some linkages here, or some links. There's a link right there, and yet another one here that looks a bit like a loop. Now the reason for the loop, from what I understand, is to allow them at the factory when they built this to calibrate it. In other words, so that, well, they got a little peg here for the 0, so they don't have to worry about that. But they would bring it up to perhaps 50 and calibrate it on a machine and adjust it here with that little loop by either squeezing it or spreading it, and that would change the calibration there so that they could check it perhaps at 50 and again at 100 to see that this is a quality piece and is within their standards or their of what they require on their blueprint. And in a cheaper one like this, maybe they're just close enough at 1 or 2 or 3 pounds, I don't know. But in a laboratory grade, it would be much more accurate. But on the average compressor, it just isn't that critical. From this angular view now, can you see the quadrant there? Quadrant meaning 1/4 of a gear, but I don't know if that is 1/4 of a gear. Riding on the little pinion and turning the shaft. Did anyone ever show you this before? I used to do this when I taught welding with an acetylene gauge.
Okay, Shabab, now let us go to the method of reading a pressure gauge. This is the important part for us in our experiments. Tested gauge, it is the gauge that we have now in our hand that we want to test it, and it has the measurement value. This gauge will take the measurement of pressure, so it is the measuring values. We will give a sample for the measuring values, which is MV, to indicate to our tested pressure gauge. Example, like this one of the tested gauge, as you see here, Shabab. This one of an example of our tested gauge. Another one, different units. If you see this one, kilopascal and inch water for the outer space, outer scale, and kilopascal for inner scale. So I have here pressure gauge with 2 units in pascal and kilopascal and inch water. This one just he mentioned 1 psi. That's mean at this value it is equal 1 psi. So it is not the unit here. Only just water and kilopascal. Just he is indicating for you this is equal to 1 psi. Just for indications. Another example, psi. and bar. See, different value. There is internal scale in red color, PSI 0 to 170, and outer scale, which is the bar from 0 to what, to 12. Another example, but see here is different value. Yes, a 1/4 per inch square for the internal, the black one, and for the outer scale, which is inch column of water, inch H2O, from 0 to 100. This is the minimum and this is maximum. طيب, reading reference. Of course, we need a reference for our readings. For sure, the reference in our experiment will be the calibration device. And these readings that comes from this calibration device, we call it the true values. And we give a symbol for it as TV. That's mean true values. Example, like our lab. This is an example, electronic gauge. We call this one as reference gauge. This is our MV, and we'll compare it to our TV. So the TV comes from this one. This is the reference gauge. Another example, we have this electronics power pressure generators. Electronic pressure generator, and it can give is called pressure calibrator. It generates a pressure with very high accuracies. It's electronic pressure, automatic pressure calibrator. This one also available in our labs. Well, it's a little bit old, very old times, but still available in our labs. Also, it is another type of our reference. So the reading here is very small and very accurate. So we can't depend on this one as a reference value. So it's the true values here. So true values, measured values. Now, how can you read the pressure gauge? As example, if you see here, this is the first example for us. We have this gauge. We have here 2 units. Red color, which is the inner one, PSI, red. Black color, which is the outer scale, in bar, 0 to 12. طيب. Now to find the range, we need to look at the scale limits, the ends of each scale. For the red one, the minimum is what? For sure, 0. Maximum is 170. It's really more than 170, but by mistake I write it as 170. It's really more than 170 here. It's a little bit more. If you can read it here, 150, 160. That's mean this one will becomes 175 in realities, but by mistake I wrote it here as 70. But let's say it's 170. The outer scale is 0 to 12 for the bar. 0 to 12 bar. This is the range. So the range for the red one, it's starting from 0 and finished at 170 psi. It is 175, but let's say it's 70. And the range for the outer scale will be from 0 bar to 12 bar, as shown in the picture. To find the span, we will take the maximum and subtract the minimum from it. So minimum, maximum minus minimum. That means the span for the inner one is 175 in reality, but let's say it's 170. And the span for the outer is 12 bar. As you see, the inner indicating for the red one, and the black one is the outer. Example number 2. If you see here, the outer scale in inch column of water, the outer one. See this one, outer one here. All this one is outer scale. is written in inch of water. See here, it's vacuum because in minus values, and pressure, it is in plus values, and you will see it in the theory class. What's the meaning of this vacuum? What's the meaning of the pressure? Inner scale, it is in the Pascal, also minus as a vacuum, plus values as a pressure. Kilopascal for the inner. To find the range, similar, the same thing. We're looking for the limits. So the minimum value for the inch water is what? Minus 30, not 0. Be careful, shabab. Minimum here is minus 30. And the maximum is what? 30. So, also the same thing for the inner one. Kilopascal. Starting from minus 7.5 and end at plus 7.5. If we want to calculate, by mistake I wrote it here is bar, not bar, sorry, it's copy mistake here. It is kilopascal. It's from minus 7.5, this one is wrong, minus 7.5 kilopascal to plus 7.5 kilopascal. To find the span, we will use the equations. The same equation, maximum minus minimum. Now look right here. For the outer one, which is the inch column of water, 30, the maximum value, 30 minus 30, this is the minimum value, and minus it becomes what? Plus. So it's mean 30 plus 30, it gives me 60. The same thing for the outer, for the inner. Kilopascal 7.5 minus 7.5, it gives me what? 7.5 kilopascal plus 7.5, which is giving what? 15 kilopascal. See the effect, ya shabab. This is the span. See, this is the span. And this one is the maximum. 7.5 is the maximum. So be careful for calculating the span and the range. Don't confuse between them. A third example, I have here also gauge. Its inner, its outer one is in red color, which is in inch of column water. The black one, it is in ounce force per inch square. To find the range, we will look also for the limits. So here 0, exactly 0 for both of them, for the inch water and for the ounce force per inch square. The minimum is 0 for both of them, and the maximum is 58 for the ounce force per inch square, and 100 for inch column of water. So the range for the red one, 0 to 100. For the black one, from 0 to 58. To calculate the span, maximum minus minimum, it gives me 100 for the inner, for the outer, and 58 for the inner, which is in the black. Now, okay, we finished formatting the pressure. Let us take the way. How can you calculate the values in percentage for each gauge? Okay, to calculate the percentage for gauge, we need to add the initial value, which is the minimum value at every calculation. At every calculation for the percentage values, you must to add the minimum value. As example here, our first one, we consider it as 170. It is really 175, but say it's 170. It starts from 0 until 175 and 170. So its span is what? The span is 170, which is mean 170 maximum minus the minimum, which was 0. It gives me 170. So then the percentage value will be as following: 0 percentage, 25, 50, 75, and so on. Its values 0. How can I find it? By this equation. The percentage, multiply it by the span and add the minimum value to them to give you the final results. As we see in here, our percentage is 0 percentage. Multiply the span. What is the span? The span is 170 divided by 100. Why? Because here a percentage. I'm talking here about percentage يا شباب. 0 over 100 mean 0 percentage. Plus the minimum value. Our minimum value in our example, the first example, is what يا شباب? The minimum value is what? 0. The maximum is what? 170. So it gives me the result as 0 psi. 25%. How can I find 25 over 100? Multiply the span 170 plus the minimum, which is 0 here. So it gives me a result as 42.5. The same thing for 50 and 75. It gives me 85, 127.5, and in the end at 100 over 100 is becomes 1. Multiply 170, it gives me 170 plus 0, it gives me 170 PSI. لاحظوا شباب, it is PSI units. PSI units. Okay. Our second example, it has a span 15 kilopascal. At 0%, 0 over 100, multiply the 15 kilopascal, the scale, plus minus 7.5 kilopascal. Where is it come from, this one? This is the minimum value شباب. See, this is our minimum value. See, minimum value of kilopascal unit scale, which is the inner one, is what? Minus 7. See, minus 7.5 here. Minus 7.5. This is the minimum, not 0 يا شباب. Be careful, not 0. So it is minus 7.5. Now, minus 7.5, we will add it, plus here يا شباب, over the result of this multiplication. Of course, the multiplication here is 0, plus minus 7.5, it gives me what? Minus 7.5. Now, let us calculate the 25%. If we multiply 25, multiply 15 kilopascal over 100, it gives me around 3.75 kilopascal. Then, add it to the minimum. Our minimum is minus 7.5 kilopascal plus the result, which is 3.75. It gives me what? Minus 3.75 kilopascal. Let's go to the 50. 50 multiply 15 kilopascal over 100. It gives me what? 7.5 kilopascal plus the minimum value, which is minus 7.5. 7.5 minus 7.5. It gives me 0 kilopascal. So this is a 0 percentage. The same thing for 75. 75 multiplied 15, it is the same results, and it's ending with 3.75 kilopascal. 100 over 100 multiplied 15 is 15 kilopascal, plus minus, which is minus in the end, 50 minus 75, it gives me what? 7.5 kilopascal. لاحظوا شباب, it is also kilopascal. لاحظوا شباب, we start at minus 7.5 and we finished at what? 7.5. And this is the resultant. 75%, safety 25%, and so on. Now, we already know how can you calculate the readings in percentage for each gauge, whatever the type of gauge. Now I want to find the error. To find the error for any scale, the unit of the true values and the measured value and the unit for the measured value should be unified. That's mean if you have true value in inch water, MV should be in inch water, or the opposite. If you have measured value in PSI, the TV should be in what? PSI. If we have as a reference value, as example, in inch column of mercury unit, and our measured value are in PSI, we need to convert either the true value from inch column mercury or to BSI, or to convert the measured value from BSI to inch column mercury. Example, I have here true values in what? In inch column of mercury, and MV in what? In BSI. So the units here are what? Are different. In this case, I cannot make a difference or a calculation between them, because why? Because this one is a unit and this is another unit. Do we need to convert the unit? Yes, we need. How to convert them? We will convert the TV from column inch of mercury to the BSI. I choose this one, and this is the better. Okay, how can you calculate it? Like this way. This is our value in inch mercury, multiply by conversions. From where I find this one, ya shabab? You remember, ya shabab, there is a line in page number 8 in your manual for the instrumentation 1 manual lab. In page number 8, you will find like this one: 14.7 BSI equal 29.9 to 9.5 inch column of mercury. This is the given, shabab. This one will be given, and you must memorize it during the exam. So from here I found this one, 14.7 here, divided by what? By these 29.9295 mercury column in inch. Then multiply it by the inch mercury. Of course, this mercury went with this mercury. 0 multiplied 14, whatever, it becomes 0. And the remaining for me is what? BSI. 0 BSI. So, to calculate the error, I will subtract the new BSI, shabab, with this BSI. Previously I have mercury, but now I have BSI with BSI. Now I can't subtract them. 0, which is the true value, and the measured value, it is 0.08558. It gives me minus 0.058 BSI. Now let's go to the other values. 86.531, this is the true, but in what? In mercury. So I'll transfer it. I will convert it from mercury, multiply it by 14.7, divided by 29.9295. It gives me what, shabab? 42.5 BSI. This is the true value, and this is the measured value. Compare them, subtract the measured value from the true value. It gives me what? Minus 0.45 BSI. لاحظوا, the unit here is what? BSI. Error unit here is BSI. It is a pressure unit. The same thing applied for the other values. It gives me minus 0.89 and minus 9.8 BSI. Okay, we transfer them. After transferring them, and we found the error after unifying the units, now we find the error. Just simply we want to calculate the error percentage. Why? In order to calculate the accuracy, ya shabab. So these things already you calculated. We finished from here. This is our error calculations, and we will calculate the error percentage. For this case, I'm using span base. What's the error percentage? It is the error, which is this one, multiply 100, because I'm talking here about percentage, divided by what? By the span. Our span for this example is what? 170. You remember the first gauge, 170 BSI. Okay, so this one error divided by 170, multiply 100, it gives me minus 0.0341, because this one is minus, and the unit here is BSI, ya shabab, and it becomes 100. only just percentage. Why? Because here is what error in what? In BSI, and the span in BSI. So error over span multiply 100, that's mean error, which is minus 0.058 BSI over the span, which is 170 BSI crossed with this one, multiply 100, because here we are talking about percentage. It gives me minus 0.0341 percentage. Now this is the percentage error. Go to the next value, which is 42.75 occurs, and we change it from column to BSI, and this is the BSI, this is our compare between them, find the difference. It gives me this one, minus 0.45. okay, I divided by true value. Why I'm using the span in the first, but I don't use the TV in it. I use TV in the other except this 0, because here if I'm using this one minus 0, which is our error, 0.58 divided by true value, the true value how much here يا شباب? is 0. see, 0. If I divide it by 0, it gives me what? Undefined infinity, undefined situation. So I can utilize this equation. So this equation is not applicable for 0 value here, not applicable. So in order to return bugs, in order to find the error percentage, I must find some values in the denominator. But here TV, it is not 0, so I can utilize this equation. So find it, minus 0.45 BSI, which is the error here يا شباب, divided by the true value, not the span. See, not the span. 42.5 BSI went with this by, multiply 100. It give me what? Minus 1.09 percentage. The same thing applied for the others values. It give me minus 100.047 minus 0.57. okay, be careful شباب. These values are taken from the gauge, our tested gauge. These values are taken from what? The calibration device. calibration device تذكروا يا شباب. This is our calibration device let's see like this one. This is calibration device these calibration device, these are the calibration device. This is the TV coming from this, but the MV I take it from where? From this. MV taken from these 3 gauges, but TV is taken from these reference gauges. Okay, return back to our example. We found MV, we found TV, we unified the units here, and we found the error between them, and we calculate the error percentage with both type, either span base or TV base, true value base. Then calculate the accuracy, which is what? This is the value, 100 minus the absolute value of error, because here either minus or positive, we don't care. Just we care about the values only. only the magnitude here. So take the values, 100 minus the error percentage, it gives me the accuracy. So my accuracy here at the first reading is 90.97, here 98.94, 98.95, 99.424 percentage. So this is my accuracy. Okay, to calculate the average accuracy for them, it's simple. See, this is a table to calculate the average. To calculate the average accuracy. We found this calculated average accuracy previously now in the previous table. Just I copy it here for simplicity, or for view simplicity. Now to calculate the average accuracy, I will take the total values of the accuracies, totals of the values of accuracy divided by the number of calculated accuracy times values. So it's 9.97 plus 9.8 plus 98.9794 plus 98.95 plus 99.424 percentage. All of them I add all of them and divide it. How many times I calculate the accuracy? 1, 2, 3, 4. I have 4 times calculations. So divide this total, the summation, over the number. It gives me what's the average accuracy, 99.321 percentage. Okay, Shabab. Now, by end of this explanation, you should understand how can you read your gauges, how can you take the measured values, how can you compare the measured values with the true values, and you should now distinguish between the location or the source for the measured values and the source for true values. And you should know how can you calculate the percentage of your gauges scales, and how can you unify the units of your gauges, and to calculate the error and the error percentage. And be careful when you use the span based or the true value based, and how can you find the accuracy in the end percentage, and finally the average accuracy of your gauges. So this is the end of this explanation, and you must start your experiment in this week and the coming week, inshallah. Thank you for listening and waiting me for the experiment number 2. Assalamu alaikum.